Hello, I'm Dr. Ana Panigasi, and I'm going to present our paper, First Trimester Preterm Preeclampsia Prediction with Metabolite Biomarkers, Differential Prediction According to Maternal Body Mass Index. Prediction of preeclampsia risk is key to inform effective maternal care. Screening for preeclampsia at 11 to 13 weeks and 6 days of gestation combines the information of maternal characteristics and medical history, measurements of mean arterial pressure, uterine artery pulsatility index, and the maternal blood levels of placental growth factor, PLGF, and the pregnancy-associated protein A, PAP-A. It can identify about 75% of women who develop preterm preeclampsia with a screen positive rate of 10%. Further improvements to preeclampsia screening tests will likely require integrating additional biomarkers. Recent research also suggests the existence of distinct maternal risk profiles associated with different phenotypes. Biomarker evaluation should therefore account for the possibility that a biomarker only predicts preeclampsia in a specific maternal phenotype. For this paper, we first verified metabolite biomarkers as preterm preeclampsia predictors in early pregnancy in all women. Then, we investigated how metabolite biomarkers predicted preterm preeclampsia across different body mass index groups. An individual's metabolome is considered to reflect, at any given time, the interaction between one's genetic makeup and external influences, like diet or environmental factors. Therefore, metabolite biomarkers are considered great candidates to capture maternal risk related to both the environment and the fetal placental unit. This was an observational case control study. Patients were attending their routine first hospital visit at King's College Hospital in London between 2010 and 2015. Within this prospective study, participants underwent a complete first trimester assessment, including the collection of blood samples for biobanking. For our studies, biomarkers were analyzed in blood samples taken between 11 and 13 weeks and 6 days of gestation. Of 2,501 pregnant patients assessed, 1,635 went on to have an uncomplicated pregnancy. This group served as the control population. 106 women developed preterm preeclampsia. The metabolites considered in this study were pre-selected based on their reported association with adverse pregnancy outcomes. After quality control, quantification data for 50 metabolites was available for further analysis. Arginine bioavailability and nitric oxide pathways are reported to be involved in the pathophysiology of preeclampsia. With that in mind, we added a set of composite biomarkers considering pairwise ratios of amino acids involved in this particular biochemical pathways. The size of the control population also allowed for robust estimation of confounding associations with parameters like maternal age, race, weight, BMI, and smoking. The necessary adjustments were made by transforming the biomarker quantification data into multiples of medians. PLGF and PAP-A were also available for all study subjects, serving as a comparator risk predictor. Using the multiples of medians normalized biomarker data as inputs, we proceeded to the predictor analysis. By comparing the adjusted median levels between the case and control groups, we confirmed 13 metabolites as preterm preeclampsia predictors. The metabolites highlighted on this chart have reached a significance level of p smaller than 0.01 for their associations. For some of those metabolites, we found an inverse regulation of levels in cases versus control than what is reported in literature. This may be due to the proper adjustments for maternal co-founders, which is typically not possible in smaller studies. We also calculated the odds ratios and 95% confidence intervals at the mean plus or minus 1 standard deviation to gauge clinical prediction merit. This cutoff corresponds to defining an at-risk population with a 16% false positive rate. The predictors delivering an odds ratio of higher than 2 are highlighted in green. When evaluating amino acid ratios as predictors, we found 7 ratios associated with preterm preeclampsia risk that are statistically significant. Any of the ratios identified as predictors involve either glutamine or ornithine. From this and the previous table, it is obvious that the effect sizes and odds ratios of the metabolite-based predictors are modest when compared to what is found for placental growth factor. Several of the metabolite-based predictors deliver a similar level of clinical utility as PAP-A. Next, we investigated whether there was an interaction between preterm preeclampsia and maternal BMI class for those biomarkers. We identified a number of metabolites for which preterm preeclampsia prediction differentiated significantly in function of maternal BMI. Most notably, ornithine was solely associated with preterm preeclampsia in the BMI below 25 group. On the other hand, medium-chain carnitines, decanoyl and dodecanoyl carnitine, as well as symmetric dimethylarginine, only have predictive merits in the BMI over 30 group. Additionally, we investigated whether there was an interaction between preterm preeclampsia and maternal BMI class for the amino acid ratios. For each BMI class, the ratios associating significantly with preterm preeclampsia are highlighted in orange. We found a distinct grouping of the ratios. 3 glutamine-based ratios showed particular association with preterm preeclampsia in the over 30 BMI class. 8 ratios are only associated with preterm preeclampsia in the BMI below 25 class, and the majority of these ratios features ornithine. Furthermore, for these metabolites and metabolites ratios, which exhibit BMI class-specific prediction patterns, the effect sizes and odds ratios are typically larger. For instance, the ratio alanine-ornithine delivers an odds ratios of about 6 in women with BMI lower than 25, which is similar to what it is found for PLGF. Now for our conclusions. With regards to whether biomarkers can have different preeclampsia prediction merits in function of maternal BMI, we were able to expose distinct differential predictions across BMI classes for several metabolites and ratios. This finding supports the notion that different maternal risk profiles exist, and they have distinct biomarker profiles associated. Our study further adds to the contemporary understanding that future research into preeclampsia prediction should account for the existence of different maternal risk profiles and phenotypes. We believe this will result in a better understanding of the etiology of preeclampsia and will translate in more informative screening tests. Our next research question will investigate whether metabolite biomarkers can be combined with PLGF and/or PAP-A to improve preterm preeclampsia prediction in a phenotypic way. Thank you for watching our video and check out our paper on the AJOG website. See you soon!